Hello everyone, welcome back to the channel. I hope you guys are doing really great. So we are back on the Leetcode Daily challenge after a series of very easy problems by Leetcode, and this one is also not much difficult. This is also really simple, but yeah, definitely worth doing. So let's see the problem statement at first. Count special triplets. You are given an integer array nums. A special triplet is defined as a triplet of indices I, j, k such that they all lie from 0 to n minus 1 and uh, n where n denotes the nums dot length. So, and you are also told that they must be present in this manner. So, nums I, nums j and nums k, they must satisfy these two equations, and you need to return the total number of special triplets in the array. Since the array may be very large, you need to return it modulo 1 plus 7. So, if you try to see, you have this index I, j, some, let's say after some point you have an index j, after some points you have an index k. So I, it is there, j is there, k is there, and the nums of I which is there, that should be equal to 2 into nums of j. So if nums of j is, let's say, x, nums of I should be 2 into nums of j, it should be 2x, and nums of k should also be 2 into nums of j, so that should also be 2x. So what do you understand by this? Any number like this, let's say it's 8 is here, 4, 8, then you need to count this as one special triplet, and you just need to return how many special triplets are there. Okay, so let me ask you some question. Let's say 3, 8, 8, 6, 4, 8, 2, 8, 1, 8. So if I ask you something like this, let's say not 1, let me call it 12 and 11. Okay, so in this question, just consider these kind of triplet 8, 4, 8. How many such triplets are there? Can you just tell me? So you see, for the when you see a 4, you see that there are 2 8s before the 4. Okay, there are 3 8s after the 4. So one triplet can be something like this, another triplet can be something like this, another triplet can be something like this. Okay, so 3 triplets you get in this way, and another 3 triplets you will get in a similar way. So I guess you do understand very easily that there can be 6 triplets, 3 plus 3 6, and that is nothing but 2 into 3 6. So two triplets before it, 3 triplets after it, so you will get 6 triplets. And so that gives me a very simple and easy idea, is that I will calculate the prefix frequency. Okay, so in a map I will just store the prefix frequency. So just before I have reached 4, I will store these all elements in a map, and as well as their frequencies. I will just keep storing that dynamically. So in the prefix frequency map, what will I have? I will have 3 1, the frequency of 3 is 1, the frequency of 8 is 2, the frequency of 6 is 1, and I will also have a total map where I will store everything. Okay, so in the total map I will have something like you see 8 occurs to be 5 times, 3 occurs 1 time, 6 occurs 1 time, 4 occurs 1 time, and so on. For other frequencies also I will store. Okay, so when I will reach 4, or in every index I will check that if the twice of the number is present in the prefix array. Okay, see the twice of the number, what is that? That is 8, right? So if the twice of the number 8 is present in the prefix array, so I will get to know how many elements twice of that are present before it. Let's say 2 is the answer, and I can also calculate how many elements are present after it. How will that be possible? From the total map. See, total elements are 5, and before it there are 2. So 5 minus 2, this 3 comes from nothing but 5 minus 2, because 5 is the total present in as the frequency in the total map, and frequency in the prefix map is 2. So 5 minus 2, definitely after this the frequency will be 3. So one thing which is right now very obvious is that in this way I can simply calculate the prefix which is before me and the frequency of twice the element which is after me, and I can just multiply, keep multiplying them. So answer plus equal to, let's say I obtain number of before elements and number of after elements like this in these variables. So answer plus equals to, I can simply do before into after. Okay, I hope that will be very simple, but there is an edge case. So let me not tell you the edge case right now. Let me solve the problem, and when there will be error, I will just tell you what is the mistake here. Okay, so let's try to understand the problems. Code this problem out. Okay, I hope, don't think this will be very difficult. So what are all the stuffs we need? We need n nums dot size, which is we also need a modulo, which we want to do 1e9 plus 7. What is the other thing? We also need the answer, right? Initialize to 0, we will simply keep incrementing the answer modulo 1e9 plus 7. Also we need two unordered maps. Map is much beneficial, unordered map is much beneficial to use than map. Okay, I hope you know it. So total map, I have one total map and I have one prefix map. Okay, so these are the two maps I have, and let me quickly populate the total map. I hope that will be very simple without any doubts. So total map of x plus plus. Okay, so I have it with me, and I will just iterate through the nums array one by one. And so yeah, I put an extra bracket over here. So now what I will do, I will try to see how many elements are present before me, twice the number of elements right now. Okay, so before there will be something like prefix map. In the prefix map, I will just see what is the count of 2 into nums of I. So twice of my element, which what is present in the before, and after can be easily calculated from total map minus prefix map, as I had already told you. So 2 into nums of I, how many it is present in the total map, as well as what was there in the before map. Okay. After this, what I can do is very simple. I can just keep adding stuffs to my answer. Answer equals to answer plus before into after. So do you think just doing this will do? No, definitely not, because this might result in a long, so we need to typecast it to long, and after this we again need to perform a modulo mod. So there will be modulo mod, and if you see, there has to be another modulo again. So there will be another modulo here, and we have our answer in this way, and we can simply return our answer. Okay, and you see, we are missing something, right? We need to update the prefix map. So after we have seen how many elements are before me, after me, and I have multiplied and added to my answer, I need to add myself into the prefix array also. That will be helpful for the future elements. So yeah, prefix map of nums of I will just keep incrementing. So yeah, that is very cool. I guess that should work. So let's see, let's try to run and check if it works or it does give some error. You see, one case we get wrong answer when there is 0. So this is a triplet which it is counting more. Okay, so I hope this should be counted once, but I hope you do understand why it is counting more, because you see what we did, see the count of zeros in the total map will be 3, and in the prefix map the count of zeros will be 1. So in 3 minus 1 it will do, and it will understand that, hey, after me number of zeros is 2, but there is only 1 0. So if there is a 0, we need to exclude ourselves. So we should not count ourselves. So the thing is that before updating our answer, you just keep a check if nums of I is 0, then what you do? You do after minus minus, because you have counted yourself also, you want to exclude yourself from the answer. So that is very simple, I guess. Yeah. So you can just try to submit it and check. I hope it will work just fine, and there should not be any difficulty. Yeah, so we get the accepted thing with a decent runtime complexity also. So yeah, that's all, I guess. That's all for this problem. I hope this was very simple for you to understand. No difficulty in this. You should have solved it on your own also, but even if you cannot, I hope you do understand it right now. So yeah, that's all for this video. I will meet you in the next video. Till then, thanks a lot.